You've probably been wondering how SQL Database in Fabric plays with the capacity model for Fabric. Learn all about it this week on Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by Amar, product manager on the SQL team. Amar, thanks so much for coming on the show.
Thank you for having me, Anna. It's great to be here.
It's great to have you back. It's been a while, but it's great to have you back. And today we're going to be talking about SQL Database in Fabric, which is in public preview today. But specifically, we're going to be talking about how consumption works and how you pay basically for SQL Database in Fabric. So can you tell us a little bit about maybe like how Fabric capacities, what those are, how they work, and where databases comes in?
Sure, Anna, happy to. So capacities, essentially what PCs have, CPUs mean for PCs, capacities mean for Fabric. So, let's get into the slide actually. It helps explain it better. Like, as you go to buy a PC, you'll see that you look at a few factors, like how many vCores you have, how many megahertz worth of capacity you have there. It's similar to Fabric, just everything is measured in terms of capacity units. And now SQL Database is part of that. So, not only like buying a PC, but it's also about like when you're making decisions around, okay, is my PC, a lot of applications around my PC, are they getting shared? Like how much capacity and throughput the CPU has? It's similar with capacity units in Fabric, where you match your capacity units with the throughput you want for your workload, and that's how you size your capacity. So it's like, everything you can think about buying a PC and CPUs for a PC, capacity units are somewhat similar for Fabric. And then, when you have multiple applications sharing the same amount of cores, you'll see the same thing when, when you're hitting the max limits of your CPU. You'll see that you start experiencing a little bit of slowness. It's the same thing with capacity units in Fabric. So it's very important to size it appropriately. And then you'll know that when you reach the max limit of your capacity units, you'll also experience slight slowness. But also important to know, like till you get to that point, you won't experience slowness at all. So, capacity units are like a new thing for like SQL Database and Fabric being part of it. But you should think about it like what CPUs are for PCs.
Awesome. I love that analogy. It's super helpful for me to wrap my head around it. What else should people know about it?
Oh, a lot of interesting things. So let's say you talk about capacities as a shared resource. So how do you share capacity across different services? You should know that each service does not need to provision their own individual level of capacity. It is shared across different resources. So like we talked about CPUs being shared across applications, a SQL data warehouse, a SQL database, all of these different options that we have on Fabric, they share the same capacity. So it's shared at a capacity level. You have like different workspaces and different artifacts and databases under that workspace. All of these share the same capacity. So that's how you should think about like capacities being a shared resource. Each service does not have to provision their own capacity.
Cool. Yeah, seems like that makes sense. And it seems like, once you get it right, that could help you really manage your cost and spending.
Good segue into the next slide, Anna. So essentially, if you size it appropriately, you pretty much, reduce your overall administration to manage the capacity. So that's very important. Like that's the whole goal of like making sure that we are reducing the amount of manual effort it takes to keep sizing capacity and knowing how much you want to provision. Because once you rightly size your capacity, it should pretty much be on autopilot and reduce your administration for a lot of these admins. So that's the goal.
Got it. But then similar to I guess different from a PC, you could be sizing it up and down whenever you want, right?
Exactly. And again, like, there are different options to do that. Like you can scale vertically, you can scale horizontally, or, there are factors with like data residency that you need to look at. So it's for essentially when you're looking at upgrading a capacity, you're trying to increase the max throughput. So for today's applications that are heavily focused on AI and ML, you need a lot of throughput. So you need to upgrade your capacity when it's not able to manage that. So that's scaling like vertically. That's how you're sizing that capacity. Also for your multi-capacity deployments, which is like scaling horizontally, because you get the right amount of isolation that you can run your test dev workloads and you can run your prod dev loads, and all of them will be on different capacity. So that's how you scale horizontally. And then for customers to know, like capacity is tied to a particular region for data residency requirements for customers and users. So that's how region availability works for a capacity. So there are all of these facets when you talk about like capacity scaling and knowing how they scale. That's important for people to know.
Got it. So it's not just fungible once you're in the capacity, but it's also flexible, within a capacity in between different capacities.
Absolutely.
But then what about when it comes to like buying this thing? How do I buy a capacity?
Oh, great question, Anna. So there are a few options there. Like you can essentially go pay as you go, which is you're trying to whatever capacity you have, you're trying to grow it, and you're trying to pay as you go in your Azure portal. But then, if you know you're going to continuously use your capacity for a year, you can always reserve instance as well. So that's how you know, depending on the time frame in which you want your capacity. But it's important to know, like, if you go reserve instance, you need to specify the amount of capacity units you want to reserve instance ahead of time. So that's how sort of you purchase a capacity, and it's pretty simple. It's on the Azure pay as you go. A lot of people know how that works, so it's going to work similarly. It's just for reserve instance, you have to specify the capacity units.
So if I do a reserved instance for like, I don't know, 16. An F16 for a year.
Yep.
And then what if I find out I need more than an F16? Like, do I just pay normal pricing on top of that, or I don't really have an option there?
Oh, you can upgrade. And I think depending on the capacity units you specify, that upgrade and the reserve instance will work accordingly.
Amazing.
Yeah.
Cool.
Yeah.
Nice.
Yeah, and it's important, like one quick trick here is to know how much throughput your capacity unit has. Simply take the size of your capacity unit and multiply it by 30 seconds. That's the sort of single time frame that platform capacity metrics app takes to process your workload and the throughput, define the throughput for your workload, to make scale-up decisions, to also like make throttling decisions. So that's a quick tip while we're on this slide for people to know as well.
Nice, that's a good one.
Yeah. There's other things to know as well, where a capacity structure is defined under a tenant. So each tenant can have multiple capacities. Under multiple capacities, each capacity would have like a workspace. Workspace would be like a project space for people to know, to share and collaborate with other creative users. So that's how the hierarchy works. You have tenant, you have multiple capacities under the tenant, you have multiple workspaces under the capacities, and each workspace you can treat it as a project space where multiple creative users can sort of collaborate. And each capacity is tied to a region, and as long as that capacity is active, all the data residency requirements of the region are fulfilled by being tied to a region. It's also important to know this pause and resume in terms of how you're calculating costs for the compute on your capacity. So essentially, to control the costs on compute, there's a feature on Fabric platform called pause and resume, and that will apply to SQL Database on Fabric as well. Which means when I want to suspend all of the execution of workloads happening on my capacity, and I would hit pause, and what that would do is it will essentially just suspend all of the execution of all the workloads that are going on my capacity, but it will also make sure that all the net new requests that are being sent are also not being honored. It will also reconcile all of the smoothing that's happening within the capacity. So these three things are important to know from the point of view of controlling the cost of your compute. But it's also important to know that every capacity is also tied to like one lake storage, and the storage is always active even though the capacity is paused. So that's something that you should know, that storage keeps on going even though your capacity is paused.
Which makes sense, because you're not consuming any vCores or CPUs, but you are consuming storage because we didn't delete all your data, right?
Exactly.
Got it. Okay, that makes a ton of sense. So this has been super helpful. I've learned a lot about the capacity model and how SQL Database plays into it. Now, I know we're going to do another episode.
Yeah.
So can you just give us a little sneak peek of like what else we're going to cover? Because there is some more that people might want to know around like monitoring and stuff, right?
Absolutely, Anna. So very excited for the next episode as well, because what we'll do is, now that everyone is acquainted with how capacities work for SQL Database in Fabric, what we'll do is take a few scenarios of capacity monitoring. Like, how do you monitor all of the usage allocation for all of these resources that you have within Fabric under your SQL Database in Fabric? And you'll also be able to tie it to a cost analysis scenario. So essentially, you look at your usage consumption, you'll identify bottlenecks of which resource is consuming the most amount of resource, but you'll also be able to correlate it with the spend and how you want to control your budget. So pretty exciting stuff ahead, I would say, Anna.
Cool, awesome. Well, thanks so much, Amar, for coming on the show. For our viewers, you're going to want to tune in for the next episode. But until then, go ahead and like this episode, leave us a comment, let us know what you think. If both episodes have been published, we'll make sure we have a link to both of those in the description. And we hope to see you next time on Data Exposed.